This is the solution for a question covering the sub-learning outcome. Calculate net force on a 2D rigid body using free body diagram and equilibrium equation from Mechanic 1. We are going to find the vertical reaction at point C in this question. Our first step is to find the force equivalents for each distributed load. We are going to look at the rectangular UDL first. We take negative 4 kN per meter, negative because it is acting in a downward direction, times the length, which is 2 meters, and we get the answer of negative 8 kN for the point load. Because this is a rectangular UDL, we know the centroid is in the middle. We take 2 meters divided by 2, which equals to 1 meter. We will draw the force pointing downward because we get the answer in negative. Next, we look at the triangular UDL. We take negative 2 kN per meter and multiply the length of 3 meters. Negative because it is acting in a downward direction. In mind that this is a triangular UDL, so we have to multiply 1/2, which is equals to negative 3 kN. The centroid of a right-angled triangle is distributed by thirds, as shown below. Therefore, we take 3 meters and multiply by 2/3. We get 2 meters on the left side and 1 meters on the right side. Now we have found all the point load and their locations. We can now start calculating for reaction at point C. The question has provided a coordinate system with positive pointing upward and to the right, and positive moments rotating counterclockwise. We will take the moment at point A and set up the equilibrium equation, which is equals to 0. Negative 8 kilonewtons times the normal distance from point A, which is 1 meter. Negative because it is causing a clockwise moment about A, plus C times 6 meters, which is causing a counterclockwise moment about A, plus negative 3 kilonewtons multiplied by 8 meters, negative because it is causing a clockwise moment about A. Rearrange the equation, we will get the vertical reaction at C is equals to 5.3 kilonewton. There will be only one reaction at C because point C is a roller support. In the diagram, we know that point A is a pin support. We will assume that it has both reactions acting vertically and horizontally. From the previous question, we have found point loads and reaction at C. Now we set up an equilibrium equation for the net force of y direction, which it must equals to 0. Negative 8 kilonewtons, negative because it is acting in a downward direction. Add positive 5.3 kilonewtons, positive because it is acting upward, plus negative 3 kilonewtons, which is acting in a downward direction. Add positive AY, which the force is acting upward. Rearrange the equation, we will get AY is equals to 5.6 kilonewton. We set up another equilibrium equation that is equals to 0 for the net force of x direction to find AX. There are no other force in this question, they're acting in the x direction, so we get AX equals to 0 kilonewton. In this question, we have found point loads in different shapes. We identify the support at point A and C, and we set up equilibrium equations to find the reaction at point A and C, which are equals to 5.3 kilonewtons for C, 5.6 kilonewtons for AY, and 0 kilonewtons for AX.